Hello my friends of Qatari Labs, welcome to this tutorial. This tutorial will be about the comparison between estimated IMERG precipitation values and real values, and this comparison will be done in QGIS 3. So here we open QGIS 3 and we are going to insert and explore new tools, and these new tools are mostly on Python and new plugins as well. And it will bring you the perspective of having a complete tool, or like the closest approach to have a complete tool to analyze something on the regional, on the spatial and the temporal scale. Okay, so what are we going to do? You will receive a folder with mostly, well, you are not going to receive the HDF5 because these are HDF5 for the whole year. This is for the entire world, for the whole 2017. Yeah, and if you want to know how to download it, is a similar process of what is stated here. Yeah, it's a process that you go to the data search, you download a file, and then with Python you download all the image, one for every day. Okay, so here we have all the image. Yeah, however, in this you will receive like a temporary file, and then you are going to receive as well a shape file of a point, and this shape file of a point is of a station where on the text file we have the station data for 2017. Okay, so that's what we have. This is the observed data, yeah, and this is the estimated IMERG precipitation data. This is as raster files, and the other as a point data. Okay, so I want this to look a little bit prettier, so I go to styles. Okay, so just to make some, and then I make some transparency. Yes, why not? And then I just add some satellite, Google satellite. Okay, and if I do, okay, here, this is, there is our, here is our precipitation station. Okay, so okay, let's start. We go to the Python console. Yep, and then we are going to set up lots of code. No, not entirely lots of code, but I like you to understand what is going on, because like in case, I mean, like I want you to understand what can be possible with this. Yeah, and then you sort out the Python code. Okay, so first of all, we do what we do. Okay, so we select the Akron Airport because this actually links to the active layer, and it will bring this point as a text. So actually, okay, here it will bring this point as a text. Okay, so I run it and say, okay, this point is as this longitude and this latitude. Okay, that's great. Okay, this is saying WGS 84 geographical coordinates. Okay, great. So then what else we are going to do? What we want is, look, here you have a lot of data. Yeah, and then what this tool, or like this approach about, is that you do not open all like one file, one raster file, one after each other. Is that you use Python in order to do that. So in order to do that, we are going to do an iteration, but in order to do an iteration, we need the names of these files as a list. So therefore we have this code. This code is for Windows, and actually it will link to this part. Yeah, and this will be your file. How say? This will be your the address for your computer. I mean, it will be different for every computer. Yep. So, and then it will so you change to this address, and this, and for your exercise you have to change it to your address. Okay, and then you create a total links, and then you filter, because actually you can have it maybe some in the file list you can have some files that are not entirely HDF files, so whether it can be TXT, shape files, and so on. So in order to filter it, you create an HDF links that is a list that is only from HDF files. Okay, great. So what else? So, well, after doing this, we are going to open, we are going to open a file. So actually here on the text file, this one will be created by the code, so I just delete it. Yeah, we are going to create a file, and then we are going to, okay, let me tell you what is going on here. This, you open a file, then you write the headers, okay, and then you open the HDF file, and then after you open, you do a geotransformation, and then from doing the geotransformation, you just identify the value associated with this station. Yep. And that's why, I mean, and then we create a temporal raster. Why do we create a temporal raster? Because actually what we want is just to identify, we want just to get the value at this point. Actually we do not want to bring the HDF5 the raster to the canvas. We don't want to cut the canvas. No, we just want to call the raster file, and then we call the raster file, we do some geotransformation, we take the value, and then we close the raster file, and then we write this value on our txt file. Okay, so you are entirely, and this is okay, this is code. You can do it, you can understand, you can see what is going on. Yep. But this code is just commands, but that you will understand as long as you practice more your Python, or you're fluent with Python, you will understand it much quicker. Okay, so we will run, and then like the code is going through the list of rasters, and then is pick up the value associated with the position of the station. Yeah, if you see, it's not so fast. Yeah, it requires maybe a minute to complete this process. And there are, I mean, if you do a year, it's okay, but if you do many stations, and then if those stations you do it for long period of time, yeah, maybe it will require more, or maybe you will think about doing this in native Python. Okay, still I haven't figured out how to do it much quicker. Okay, so we are on half of the year, and what this code is just is picking up this value, that is the precipitation millimeters, and it will store here. Okay, great. Something that I have missed is that in order to get IPython inside QGIS, we need to run QGIS as an administrator, because that's how we are going to deal with insert package inside QGIS. Okay, yep. So how do we do this? Is okay, let's finish this first. Okay, the purpose of this tutorial, I mean, you can do it like couple in between Jupyter notebook and QGIS, but I wanted to do it everything in just one it's just one tool. Okay, okay, great. So if you have seen here, we have already the precipitation, and then on the precipitation these are the values, one for every day. Okay, great, but we need to, okay, we need to install a plugin that is called, what is called this plugin is called IPython. The IPython console, and the IPython console requires that you have the Jupyter, and we need as well to have the Jupyter and the Qt console, I guess. I don't remember if I have done them. And Jupyter, maybe Qt console, and then you need Pandas as well. So, but in order to do what we are going to do, we need to restart QGIS, but on as administrator. Okay, so I just close this. I can store my project. Why not? Okay, I have a store, so I will, because I want to store the settings of this tutorial, I close it, and then I will open again, but as an administrator. Okay, why as administrator? Because we will install Python 3 package inside QGIS. Okay, yep, we have this. Okay, so here we go, we open the Python console, and then we, with this code, and this is a very interesting code, first this code will run Jupyter. Okay, so actually for me I have already Jupyter installed. Okay, but if you need, I mean, it will take more time for you if you are going to install it. Okay, and then if I want to install Pandas in QGIS, I have to run this. Okay, okay, so it's really easy to install Python package inside QGIS. Okay, so yeah, and then I mean, this is another approach than to use the prompt, the OSG prompt. Okay, there is another tool. Okay, so we go to the plugins, and then we say IPython, and then I will reinstall it, but you will install, you can install it. Okay, okay, and then you can have it as docked or as a window. I will use it. I don't need this anymore. Don't need this anymore. And then I want it as dock. Okay, great. So this first we upload some Matplotlib, Pandas, and then we print where we are. So just drop. Okay, and then we are not in we are in the right now, since we have closed Windows, close the QGIS, we are on the root of QGIS, but we need to change to the folder where we were working. So wait. Okay, so here we change to our working folder. Okay, that's right, it's great. Okay, and then we are going to open the observe acron, and then it will understand that these are the dates and the index are the column and these are dates. Okay, so this is the index, so you have one index for every day of 2017. Yep. Okay, and then you have the and then what you do is you will create, this is the last, precipitation is the last column, but then you will create a new column. Okay, first I have to sorry. First I have to, yeah, I want to, and then I open the precipitation. Yeah. Okay. Yeah, here I have the precipitation. This is the IMERG value of precipitation, and then what I will do is I will actually insert here in this data frame one new precipitation column. Yeah, and this new precipitation column will be of the IMERG precipitation. That's why it will be called IMERG. Okay, so here we have, this is precipitation, this is IMERG. Okay, and by using the matplotlib tools and the matplotlib interline, we can create comparison in between the precipitation, like the observed precipitation and the IMERG precipitation, and then we can do it here in QGIS. Okay, so this is the magic. Yeah, because actually this is the comparison in between what is coming on from the IMERG estimate of precipitation estimate and the observed. Okay, and then you can have in one tool both image. You can have it the spatial analysis, and then like you can do a spatial analysis and temporal analysis as well. Yeah, and this is very powerful. And then I think that the future of GIS is to be a spatial temporal information system. So it will be GTIS, something like that. Yeah, because we need to do more we need to process more data spatially. Okay, so here what it will be on the description of this video is a post or like a discussion if we can optimize this. Okay, so if we can do something better, because if you see well, here we see some days where maybe I think, let me wait. Observe is the blue line, and the orange is the orange line. Let me try something. It was not in the script. Let me try something. Great, so I have inserted, what I have done is I have inserted a legend here. Okay, so if you see, there are some days where there is an estimation of precipitation, but where actually there is no precipitation. Okay, and there are some days where there is precipitation and the image has not understood this, and so there is precipitation, there is recorded precipitation, but there is no estimated precipitation. Yeah, okay, and there are some days that there is less estimated precipitation than observed precipitation, And okay, if you see, these are gaps in between the observed and the estimated. Okay, and these gaps could be, I mean, it will be really tough to improve this just with the use of, I mean, if you want to do some artificial intelligence or something like that, yeah, or neural network, like because actually the IMERG come from the I mean, it's a product from some image, and with the product you cannot improve it, but maybe if you have access to the input to that create this product, maybe you can do something better. Okay, so thank you for following us. Thank you for following Hatari Labs. What is Hatari Labs? Hatari Labs is a blog dedicated to knowledge sharing in modeling and data analysis. Okay, so and we hope that our tutorial will be helpful for you. If you like this video and the videos on our channel, please subscribe and share it with your friends on your social networks. My name is Saul Montoya. It was a pleasure to bring you this tutorial, and hope to see you in coming tutorials in our channel. Okay, see you and bye.